All right, so now the last part to do with rationalizing the denominator is when you have something that's called the conjugate. So before, when we had two things that were multiplied together, what we could do is just multiply by whatever the square root is. We can't do that when things are added and subtracted. So when it's added or subtracted, we have to use what's called the conjugate. And the conjugate is the opposite of whatever's in the bottom. Okay, so the bottom says 3 plus square root of 5. So we're now going to do 3 minus the square root of 5. Again, we have to do that to the top and the bottom, because really what we're doing is we're multiplying it by 1, if you think about it, because these are the same, so it's like multiplying it by 1. If you only did it to the bottom, you'd be really affecting the equation. All right, so what I want to do is take this and distribute it to both. So that's going to give me 12, and then I'm going to get minus 4 root 5. Okay, on the bottom, I have to FOIL this. So I'm going to come out to the side over here and do that. So my first is going to be 9, because it's 3 times 3. My outer is going to be negative 3 root 5. My inner is going to be a positive 3 root 5. And my last is going to be negative square root of 25. Okay, so here's what the benefit of this is. What we're trying to do is not have any square roots left in the bottom. So when we combine our like terms, this is a positive and a negative, so that's going to give me 0. These are going to go away. What I know is I know that the square root of 25 is 5, and this negative sign out in front makes it negative 5. Okay, so when I put these two together, I really get 4. So now I have to look at all the outsides. I say, okay, is there anything that divides these three numbers perfectly? Because they're on the outside. Well, 4 goes into all of them perfectly. So if I divide them all by 4, I get 3, 1, and 1. So that leads me to this. But I know that I don't need all these 1s sitting here. So this is really going to become 3 minus the square root of 5 as my final answer to that. Okay, so let's do one more just like this. So again, what I have is 4 minus root 2. Well, I want to do the conjugate. The conjugate is the opposite, so this is going to be 4 plus root 2. Have to do that to both the top and the bottom. All right, so I want to take this and distribute it to both. So that's going to give me 8 plus 2 root 2 as my numerator. The bottom I'm going to have to FOIL. So my first is 4 times 4, which is 16. Then I go to my outer. So it's 4 times the square root of 2, which is 4 root 2. My inner is negative root 2 times positive 4, so negative 4 root 2. And then my last, which is a negative square root of 4. Okay, so again, like we said, the benefit of this is that your outer and your inner are always going to add up to 0. So they go away. That's what we want because we don't want any square roots. We also know that the square root of 4 is 2, and this negative sign stays with it, so negative root 2. So I put together my numbers, and I get 14. So my denominator on this should be 14. Now I need to look at all the outsides. I look at 8, I look at 2, I look at 14. Is there anything that divides all of those? Well, yeah, 2 does. So if I divide all of these by 2, here's what I get. So my final answer is 4 plus square root of 2, because I don't have to write that 1, all over 7 as my final answer.